Greetings, my name is Chris McLemore and I represent Huntsville Space Professionals. We're a non-profit that preserves and promotes space professionals everywhere. We also work to increase the accessibility to space education resources, much like the one that's standing next to me now. This demonstrator is what I would like to show you today. This is the Space Fizix demonstrator, and it illustrates the effects of a reduced gravity environment. The payload that I am going to show you today is the candle flame payload. Have you ever wondered what makes a candle flame the teardrop shape? The teardrop shape of a candle flame comes from gravity-driven buoyancy. The thought of hot air rises, cold air falls. And this is something that has been proven over and over again. This action, which is invisible to the naked eye, shapes the candle flame into the teardrop shape. Now, when we put this candle flame into a free-falling environment or a reduced gravity environment, that flame shape is going to change. And I will show you right now just how that's going to happen. What we have is a standard plastic shoebox that you can find at any home improvement store, and we have a wireless camera. A camera that operates off of 4 AA batteries. I will show them to you individually. This wireless camera sends video via wireless radio signal to a receiver, much like this one right here, and then this receiver goes to a device called an A to D converter, and that A to D stands for analog to digital. That takes the analog signal, converts it to digital, and then pulls it over into a laptop. It is with the laptop that this magic part of this whole demonstrator happens, because we're able to slow down what the video captures. What we have here is the candle flame payload. It is a Altoids container with a candle in it, held down with some paraffin wax and a lot of screen wrapped around it. Now the screen, what it is used for, is to transfer the heat from the candle, because we're putting this into a plastic box and we wouldn't want the plastic box to catch fire. So this is approximately 160 to 200 layers of screen on top, and about 40 layers, individually layers around the sides and back, that protects the payload container. This right here is just a PVC structure, much like your standard swing set. It's got a pulley system that carries the box to the top of the structure, and then we release it, and it hits pillows down below. What I'm going to show you now is one demonstration. For this next part, I really wanted you to see what happens when we've hit the play button on the computer. Play button's on, and you see the camera. Now what you are seeing is the screen for the candle. Now what you are seeing is the screen for the candle flame payload. Here's the box, there's the camera, and there's the candle. Now, what we're going to do is I'm going to light the candle, and then I'm going to place it into the lid and hoist it up. What we have here is the candle flame inside the box, lit. Try to move that up there so you can see it. Now I'm going to hit import to begin recording. And now you will see what happens when we drop the drop package. Did you see what happened? Well, with this video editing software, what we are able to do is edit out some of the dead time. We can take this viewfinder and push it up to right before the action point, and then we can come back a little bit, grab all that dead time out and delete it. Then we can get after the drop as well, take all that dead time out. Now we have about a fraction of a second of the actual drop. We can also take this under slow motion and see the effects of free fall in slow motion. To make this clip into slow motion, we just go down and select it. We would like it at a slower playback speed. Now we can watch the drop we just did on this candle flame. What we have here is a standard oil drip toy. You may recognize it. The colored liquid falls depending on what end you have it flipped over, and then you can turn it back over. This one presents a highly visual effect, what the effects of a reduced gravity environment are on these falling droplets. You hit record on the camera. As you may recall, this is the colored liquid payload inside the payload bay, and I have the box turned over so that all the liquid will drain to the other side. Now hit camera. I have the button. The camera is recording. We're going to flip it over, and then we are going to drop it. 3, 2, 1, drop. Now, for the drop we just watched, we'll show you how we edit out the dead time. First I take this and I find the place where it starts falling, and grab right beneath the ruler, hit delete. Then you fast forward to after it's fallen, which is probably right there, and then edit it out and delete out the rest. Select the timer and the clip, then you select this little selector. Now, there it is in normal gravity. It's about to be in free fall. I'll try to zoom in there. Do you see that? Let's do that again. Look. That apparent weightlessness is another word for free fall. This next payload is called the repulsive magnet stand, and what you have here is a repulsive magnets, ringlet magnets, that is a balance between gravity and the repulsive forces of both magnets. Now, if we were to turn gravity off for, say, a couple of seconds, what do you think will happen to the red magnet? So what we have here is the magnet stand, and I want to hit record and watch what happens. when the drop's made. I've edited out the dead time, and this is what the repulsive magnet stands look like between normal gravity and free fall. You want to see that again? Thank you for giving me this opportunity to share with you my Space Fizix demonstrator. I hope you've learned something new about the effects of free fall on fire, water, and magnetism. Microgravity, or the state of free fall, is important to the Senatobia launch because as soon as the balloon reaches the top of the atmosphere, the balloon pops and it becomes a free-falling object as it captures wonderful images of the side of the Earth from the edge of space. Thank you and have a good day.